but it was word problems, so I typed them all out for you. How kind of me. And I made little boxes for you. Also kind of me. Okay. So optimization is a great application of the calculus you've been doing with max and mins. So some of these, though, like question number 1, you'd probably be able to do it with just basic algebra skills or just plugging and chugging. But I'm going to show you, we got to get used to how to do it according to calculus, okay? So even though you're like, I can do this, because that was the last class. They were like, I can do this without calculus. Okay, fine. But you got to learn how to do it the calculus way, too, so that way you get better at doing optimization, the harder problems. All right, so here's the question number 1. Find 2 positive numbers whose product is 81. Thanks, honey.
I'll put my name's on there.
Whose product is 81 and whose sum is a minimum. Okay? And you probably can think of one right now. Anybody think of 2 numbers whose product is 81 and whose sum would be a minimum?
What does it mean if its sum is a minimum?
That would be the smallest amount of sum that you could possibly do. So, for example, 1 and 81. Don't they product 81? But what's their sum?
82.
Is that the minimum that we could have?
No.
Okay. So this right here, this statement right here is what we call your objective. Okay? So in all of optimization problems, you have to write 2 equations. One is called the objective and one is called the constraint. 2 positive numbers whose product is 81 is what we call your constraint. Here's why. I can say x, y, 2 numbers multiplied together make 81, right? That is my constraint. My objective, though, is to get the minimum value of those 2 numbers, meaning that their sum is a minimum. Usually your objective has a bunch of letters in it, as you can see this one does. Now, you could have called this, I called it M. You could call it whatever you want to call it, Z, I don't know. But I'm trying to find 2 numbers who multiply to 81, but their sum is the smallest amount of value that I could possibly get from those 2 numbers. All right, once you do that, once you've established these 2 equations, you are going to solve the constraint for a variable, whichever variable you want. So let's look at the constraint. Which variable do you want? I go with y, because I'm just a person. I always solve for y. How do you solve this for y? What would that be? Okay. Then go to part C. See, I put this in a whole nice chart for you. You are going to replace this constraint into the objective. So here's your objective formula. You're going to replace the value of y into that objective. So I'm going to write x plus 81 over x equals n. But we're going to have to do some calculus. So I'm actually going to rewrite this as x plus 81 x to the negative 1. Y'all with me on where I got that? Right? Elevator pass. All right, so we write 2 equations. We solve one of the equations, the constraint one. We replace it into the objective. The last is the calculus-y part. You're going to take a derivative of that. You're going to set it equal to 0, and you're going to actually solve the problem. So let's take a derivative of this. It's been a while now. What's the derivative of x?
1.
Yay! What's the derivative of 81x to the negative 1?
Negative 81x to the negative 2.
Beautiful. Equals m derivative. The prime of it, whatever. You're going to set this equal to 0. And again, I don't want my negative 81, so I'm going to move it over here. I'm going to have 81x to the negative 2 equals 1. But I'm going to rewrite this as 81 over x squared equals 1. Whoops. What would that be? X squared equals what? 81. And what are my 2 numbers then if I take a square root? 9 and negative 9, right? But go back up to the top, find 2 positive numbers. So do I choose the negative 9? No. So where did what go?
Yeah.
Well, we're just taking the derivative of that function, honey. So we don't, it's unnecessary. All right, so if x is 9, go back up here to this equation. What's 81 divided by 9 then? 9. So it turned out for us that the 2 values that would multiply to 81 and that would make the minimum amount of value that would still multiply to 81 would be 9 and 9, surprisingly enough. Okay, 81 and 1 they multiply to 81, but they make, what's their minimum? 82. What's this minimum? 18. Okay. But we just answered the question whose sum is the minimum. So you could say something like 9 times 9 is 18, which is the minimum, but your dimensions would be, the numbers would be 9 and 9. So again, that was very easy. Let's start working on harder problems. Find the dimensions of a rectangle with a perimeter of 200 feet and an area as large as possible. And an area as large as possible. Okay, so ready? This is your objective. To get an area as large as possible. You have a rectangle. With rectangle, I usually do length and width. So I usually go around and I'll say, this is my length, this is my width, this is my length, this is my width. Okay? How would you write the objective formula? What would the objective formula be? So yeah, or area, you could write max. Some people have write M here, but I'm just gonna write A equals LW. That is my objective. My objective is to find the largest possible area. The perimeter, okay, do you all remember perimeter of a rectangle?
It's just adding up all the sides.
So what would it be? 2L, 2W equals, and I'm not gonna put P here because I actually know the perimeter. What's the perimeter? 200. By the way, I'm actually going to reduce this to a simpler equation. If I divide everything by 2 right now, I would have L plus W equals 100. That is my constraint. Did you all understand where I got those now? Okay. Go to box number 2. You are going to solve the constraint for a variable. Which variable you want to solve for? It doesn't matter. Length, okay? So L would be equal to 100 minus W. Take that constraint now and plug it into the objective equation for the L letter. So you're going to write area equals, instead of writing L, you're going to put 100 minus W. And then in replace of W, you're just going to put W. Now again, we're taking a derivative of this, so I'm going to make this look as simple as I can. Just distribute. What would that be? 100W minus W squared. Okay, there's A. So now let's, in this box, take a derivative. What's the derivative of 100W? Just 100. What's the derivative of negative W squared? Minus 2W. Set it equal to 0. Solve. I got 50. What would the length then be? 50. The dimensions of a box that make the largest area, and this is something I assumed you had known. Do you know that a square always makes the largest possible area? So 50 by 50, which is 2,500 units squared. What are we at? What's my unit feet squared? That would be my largest area. But the dimensions of the box would be 50 by 50.
How would you do this task? Do it small.
I'll show you another way. The minimum. I'll show you. We got to keep going, but I'll come show you later. All right. A farmer has 600 feet of fencing and wants to create a rectangular field along the river. He needs no fence along the river, obviously. What are the dimensions of the field that has the largest area? Okay, so let me draw this out for you. You got a river. The farmer puts a fence like this, like a 3-sided fence, right? Your cow's not going to jump into the river. He might. I don't know. I have no idea, honestly. All right. So I have a width, and a length. So if I'm looking at the perimeter, according to this, I have 600 feet of fencing, which is my perimeter. So how would I write this perimeter, though?
W plus L
Equals 600. That is your constraint. Okay. What's my objective? My objective is to find the field with the largest area. So again, area is length times width. That is my objective. All right, so solve this constraint for a variable. I'm going to give you a minute to do this, B, C, and see if you can do D. Solve the constraint for a variable. Obviously, which variable would you choose? L. Replace it into the objective. Take derivative, set it equal to 0, and solve. So my constraint is 600 minus 2W, I believe, and then my area would be 600W minus 2W squared. Is that what you have? Okay, take a derivative. What's the derivative of 600W? What's the derivative of this? Set it equal to 0. Solve. I can't remember. Is that 150-ish? Okay, thank you. So the width would be 150. How do I find the length? You plug this back into right above it. Look, L equals 600 minus 2 whatever times W is. I just found W. 2 times 150 is 300. 600 minus 300 is 300. The length would be 300. That right there would make the field have the largest max without having that extra fence along the river. Okay? And that max would be 300 times 150, which is 45,000.
It's not a square.
It's not a square, no, for that one, no.
But you said that a square always has the largest area.
Yeah, if you know the perimeter parts of all the third side of all 4 sides. That one actually works out this way. All right, so let's see if we can do 4 now. Oh yeah, sure, I'm sorry, honey. A farmer wishes to create a rectangular field along a river. Again, whenever he's creating it along a river, there's no fencing there. I just didn't type it in here. With an area of 10,000. I switched this up on you. Okay. What are the dimensions of the fields requiring the least amount of fencing? See if you can write the 2 equations now. The area is 10,000. I wasn't giving you fencing. Picture's the same. So what do you think my equation would now look like? What would I write? Anybody want to give me one of them?
LW equals 10,000.
LW equals 10,000. That is your constraint. Constraint usually has numbers in it, and numbers and then a letter that you can solve for singularly. Okay. All right. So then if my area, this is my area, which is my constraint, then I'm actually asking for the dimensions of the field requiring the least amount of fencing, which is my objective to find a perimeter. Fencing is a perimeter. So my perimeter would be 2W plus L equals P. I don't know the amount of fencing I need. P, we'll call it. That's my objective. All right, so now take the constraint that we just found and solve for whatever letter you want. What do you want to solve for? L, I guess. 10,000 over W. Part C, take that and place it in here. So 2W plus 10,000 over W equals P. Now listen, remember you're taking a derivative of this. So let's rewrite that. Let's rewrite that as 10,000 W to the what? Okay. Now go to part D. Let's take a derivative of that perimeter. The derivative of the perimeter with respect to W would be 2, and then what? Minus 10,000, W to the negative 2, set it equal to 0, and solve. So I would bring this over and make it positives. I would elevate or pass that down, so 10,000 over W squared. So crisscross multiply would be 2W squared equals 10,000. 5,000, I got to remember how much that is. I think I have it in my calculator. Square root of 5,000 is plus or minus 70.7. Do I use the minus? No, I'm talking about fencing. You don't have minus 70 feet of fencing, okay? You have positive 70.7 feet of fencing. So then how do I find the L? Plug that right back in here. Do 10,000 divided by 70.7, which I have in my calculator already because I did it in the last class. 141.4. That right there would be the dimensions that would require the least amount of fencing. And if you want to find out what the least amount of fencing would be, you can just add them up. How you doing so far on this? Okay. So now we're going to get progressively harder. 5 is, I'm going to tell you right now, good old Georgie boy in the last class, he's like, there's such an easier way to do number 5. Yes, there is. There is. Okay. But I'm doing this to show you on a homework problem tonight where you can't do it the easy way. You have to actually do it the calculus-y way. So if you bear with me and learn how to do it the calculus way, even though there is definitely a much easier way to do this. So you are asked in question number 5 to find the point on the line, y equals 3x plus 5, that is closest to the origin. So let me just give you a visual for this. Did I write closet? I did, right? Sorry. I'm sorry that I typed this out for you for your benefit.
Hey, you're math. You're not a language teacher.
Wow. Still
I feel like spaghetti.
making fun of me. Thank you so much.
I'll make fun of you.
I'm doing something wrong. 1, 2,
It wasn't.
down 1, 2, 3, over. Okay.
I was actually trying to encourage.
So we're making a closet. I hate you so much. Okay. This right here is your constraint. Y equals 3x plus 5. It's already set equal to y. It's a beautiful thing. That's your constraint, okay? Your objective, and you might not remember this from geometry. Your objective is to find the point that is closest to the origin. And this you may not remember from geometry, but I'm going to refresh you. The shortest distance between 2 points is a line, more particularly a perpendicular to that line. The shortest distance between 2 points is a perpendicular line. Where's the perpendicular? So you actually have to find, did you hear what I just said? Distance. To find distance, you could use the distance formula, but that uses x1 and y1s, right? Another way to find distance, let me just blow this up for you right here, of a triangle, to find this right here, D. Well, what do you do? What do you always do for a right triangle? You use what? Pythagorean theorem. Call this x and call this y. So Pythagorean theorem says that x squared plus y squared would equal the d squared. I mean, you could call it z if you want to. I'm just calling it d. And I'm just going to solve for the distance. Distance would be the square root of x squared plus y squared, okay? This is your objective. Your objective is to find the distance, the shortest distance between 2 points is a line. Again, there is a much easier way to do this. I mean, you could do slope and then find 2 points. It's much easier, but I'm letting you know on tonight's homework, you're not going to actually have a line. You're going to have a parabola. So you're going to have to do this problem, okay? All right, so solve the constraint. Would you agree that this is already solved for a variable? All right, so now let's do some algebra. Let's take this and plug it in here for y. Down here. So d is equal to the square root of x squared plus y is this. Y is 3x plus 5. 3x plus 5 squared. Okay, yeah. All right, so now you have to actually FOIL this out. I hope you're all good at foiling fast as I am.
Why can't you
Well,
just take the square root?
You'd have a plus or minus.
Well,
You are doing it, you're going to do you're not going to do FLA. You're going to do square this first, which would be 9x squared. Multiply these together would be 15x, and then double it would be 30, and then square that would be 25. There you go. I just FOILed it fast for you. Now clean this up. This would be what? 10x squared plus 30x plus 25, and then watch what I'm about to do. To the power of 1/2. Why am I doing that? Because I'm going to have to take a derivative. So let's do part D, take a derivative. Do you remember how to take a derivative when it looks like that? The U, good job, Jack.
What?
U.
what are we doing to the left again?
The square root is a 1/2, okay? So if you remember to do the U, you put the 1/2 in front, times the entire thing, 30x plus 25, to what power now? What would be that up here? To the negative 1/2 But then what do you have to attach? The derivative of the inside, which would be 20x plus 30. Okay. Now I know this looks terrible. And by the way, you got to set that equal to 0 and solve. And you're like, this looks awful, but it's actually not that bad. Bear with me as I help you out through this. Take a half of that. Couldn't you take a half of that? What is that? 10x plus 15. And then where does this guy go? On the bottom. 10x squared plus 30x plus 25 to the 1/2 power. Set equals 0. We don't necessarily need to get the bottom because that would just give us a fraction with a denominator 0. We don't need to know where those zeros are at. We just really need to know the 0 on the top. So if 10x plus 15 equals 0, what does x equal? Yeah, oh, you're right. Thank you. Ooh, you saved me there. Negative 3/2 or 1.5. Yeah. Negative 1.5. Where would the y value be then? Where do I, because this is a coordinate. Remember, we're finding the point.
Plug that into the constraint.
Plug that into the constraint right up here. 3 times negative 1.5 and then add 5. I'm just going to give it to you. It's 0.5. The point that is the shortest distance to that line is that one right there. Now, again, is there a much easier way? There is, y'all. And I'm sorry about that, but just know how to do it this way so that it can help you out for your future. All right, we got 2 more. These are our last 2 hardest ones, and then we will be good to go. Yes, sir.
Where did you get the 20x plus 30 again?
Remember the chain rule says that when you do a U problem, you have to take the derivative of what's inside.
And then why did it end up being 10x plus 15 on the top?
Half of 20 is 10x, half of 30 is 15.
Oh, I didn't see that.
I just took a half. Yep.
Gotcha.
All right. Number 6. What is the largest possible volume of a box with a square base and an open top that can be produced using 900 centimeters squared of material?
Same as the other one.
No, it's not.
No river, no like the river.
Okay. Do you remember me handing you a worksheet that said TBT on it, throwback Thursday, but I gave it to you on a Tuesday? And it was a box
Or that open-
problem. Yes. And you wonder why Mrs. Seta does these. That's a terrible box. Thank you. I know. I'm sorry. Okay. So let me give you a visual of this real quick. You have a square base, but you have an open top. There's a reason that's in there. Open top, square base. Okay. We are asked to find the largest possible volume. Is that my objective or my constraint right here? That is my objective. My objective is to find the largest possible volume. Do you all remember what volume of a box is? And what is volume for a box?
Times width, times height.
Length with height, right? Okay, well, but if I have a square base, then my height would be h, but what would both of these be?
Length and height.
Length and length or W and W. It's up to you however you want to call it. I'm going to call it WW. I don't know. So my formula for volume would actually be what?
H2W.
Not H2W, but H,
4W.
no,
Squared.
HW squared. Good job. Or W squared H. W times H. W squared H. That is my objective.
Because there's no length.
The length is the same as the width. Yeah. Okay. So now what is our constraint? Well, let's again read what we got. We're producing something with 900 centimeters squared of material. Anytime something is squared, what am I talking about? Surface area. Now, my boy Tyler knows this because I have given him this formula and he's like, this formula has changed his life teaching 7th and 8th graders. The formula for surface area is, and you can write this down if you want to, but I'm going to explain it in a minute. It's 2 LWs plus 2 WH plus 2, what am I missing? LH. Thank you. That's the formula for any box to find the surface area. 2 LWs, 2 LHs, 2 WHs. We have a problem though. We do not have 2 of something. We have 1 of something, but we have 2 of everything else.
2 LW.
The 2 LW, and again, remember L is actually no longer an L. L is a what? W. So this is really, I should really cross it off and call it W. Cross this one off and call it W. Okay. So which one is actually only 1 of? Because I have an open top.
First one, so it should be
This first one should just be one of, right? Because I have a bottom, but I don't have the top. Are you with me? So this would actually be 1W squared. This would stay WH. That would be the side of the box times the other side of the box. And this would stay WH. That would be the back of the box times the front of the box. Are you all with me? Front, back, right, left, bottom, but I don't have a top. So what do these make together?
4W.
Okay. And what were we told is the actual surface area? Because we were actually given a number. What was it? 900. This is your constraint, kids. Okay. All right. So now we got to solve the, oh, I did something wrong. Did I do something wrong here? That shouldn't be, oh, that's a 1. That's not an L. See, I thought that was an L. That's terrible. All right. What do you want to solve the constraint for? What letter would be the best letter to solve for? W or for H? Let's solve for H. H equals, and again, that's a 1. Oh my gosh, I got to change that because I keep thinking it's an L. So H would be, what do I have? 900 minus W squared divided by 4W. Is that right? Okay. I'm going to take that. I'm going to replace it into the objective. Replace that in for H. So now my formula looks like this. W squared times H. Well, H is 900 minus W squared divided by 4W. And I'm going to simplify this as best I can because remember, you got to take a derivative. And I do not want to do product quotient rule. No way. So I'm going to simplify this as best I can. So let's see. I can get rid of a W and have a W right here. W times 900 is 900W. W times W squared is W cubed. I'm going to divide each of these by 4 because remember, when you have a fraction, you can separate it. 900 divided by 4 is 225. So I'm going to call this 225W. And this one I'm actually going to rewrite as 1/4 W cubed. Again, why am I doing this? Because I got to take a derivative. And that's much easier to take a derivative of. Take a derivative right now of 225W. What would it be? 225. See how much easier that was? Take a derivative of 1/4 W cubed. What would that be? 3/4 W squared. Set it equal to 0, y'all, and try to solve it right now for me. And see, find H. What would I do to find the 8? Plug it in right up here. Right up here. Do 900 minus 17.3 squared divided by 4 times 17.3. So I'm going to do that for you because I see a lot of you don't have calculators. Divided by 4 times. I got 8.7-ish. See if that's what I got over here on my answer. Anybody else get 8.7? You got 8.7? Okay. But make sure you answer the question. Yeah, I got 8.7. Okay. Question says, what is the largest possible volume? So what do I do there? Plug it into the actual volume. So if my W is 17.3, square it. Volume equals W squared times H. So 17.3 squared times the height of 8.7. 17.3 squared times 8.7. The largest possible volume is 2,603.8 centimeters cubed. That is the largest possible volume. Why is this important, guys? There are people doing this every day, making bank, because this is what they have to figure out, like cereal boxes. What's the best cereal box that I can construct that holds the most amount of cereal inside of it using the least amount of material? All right. There is one here that I want to do. I don't think I have time. Do I? No. So I might put this up on the LMS. You'll have to see it. Let me give you all your homework worksheets for tonight. And we call that quits. And then you can go.